Okay, in this video, we are going to look at proving trig identities or trig functions. Please check out my previous video where I did a quick rundown on the basics of trig identities, as well as the identities for you to remember and the basic ones you can derive. So in this video, I'm going to take you through the identities as well as the functions, how you prove them, how you identify them, and how to identify what to use in order to prove them, which is very important. I did this video on the request of some of the students who emailed me around these videos of what they wanted to see, and I think this is a very important section from my experience for any trig section that I had in the exam or in the test. I've always had to prove some sort of trig identity. So let's jump into it, and I'm going to start off by showing you some basic rules you should remember when trying to prove these identities. And of course, the simplest rule is to ensure that we have the left hand side equal to the right hand side. Okay, and it is always important to try to have that knowledge or intuition to the point where you can decide which side you want to use for proving. You don't always have to use the left hand side, you don't always have to use the right hand side, but follow the question, because sometimes the question itself tells you which side you should use in order to prove that both sides are equal or both sides are the same. And that follows into step 2 of the rules that you should try to look at, and that is for step 2 we are going to go ahead and say that we must always convert to the basics. Okay, and the basic trig function that we know is sine and cos. Okay, so sine and cos, so this will actually feed into point 1, or the first rule that I've shown you, that if you can see that you can convert the left hand side to sine and cos, then start with your left hand side. If you can see that you can convert the right hand side to sine and cos, go with the right hand side. Okay, the third step, or the third rule when going about this, is to always know your identities, right? Know the identities, because when you know the identities, it will make life very simple. So check out my previous video where I showed you some of them. But this will make your life very simple, because you would be able to identify from your question, or while you are trying to prove it, that you can use simple identities such as sine squared x plus cos squared x is equal to 1. And you will see that I will be using this a lot going through this this entire video, which is the basics. So if you can identify that that's the specific identity that you need to use, you would be able to prove that identity faster, and you won't get stuck, right? So just some common identities for you to remember or recap from my previous video. So some common identities, and I've just spoken to one now, and that is sine squared x plus cos squared x is equal to 1. So this is the most important identity to remember. From here you can go ahead and derive the rest, so please check out my previous video. I show you how you can do that. So the next one is the identity of 1 plus tan squared x, and that's equal to sec squared x. And then you have 1 plus cot squared x, and that's equal to cosec squared x. Okay, what else do we need to know or remember? So we know that tan is equal to sine of x over cos of x. we know that cot is the inverse of tan, so that's just equal to cos x over sine x, or tan, like I said, is equal to 1 over cot of x. Sec of x is equal to 1 over cos of x, and cosec is 1 over sine of x. Okay, so just remember these, some basic or most common ones, and let's get cracking into the first example. So in our first example, let me just change the color, let's use yellow, where the question might say, let's verify or prove that sine of x, sec of x, is equal to tan of x. Okay, now remember the rules, or the basic rules I said that we need to do. We need to pick the left hand side. We need to show that the left hand side is equal to the right hand side, so we need to choose one of these sides. Okay, step 1. Step 2 is to ensure that we can make everything, I'm actually going to write this out, sine or cosine on the side we choose. Okay, so I can already see we have sine on the left hand side and we have sec. And sec, so what we did above, sec of x is basically equal to 1 over cos of x. So I can see that I can make this entire left hand side in terms of sine or cosine. So I'm going to choose the left hand side. By doing so, we then have sine of x. Okay, we said we're going to make sec equal to 1 over cos of x. Okay, and we need to show that that's equal to tan of x. Okay, which is what's on our right hand side. So if I multiply this out, I can already see that this is sine of x over cos of x, and we know that sine of x over cos of x is actually tan of x. So we have tan of x is equal to tan of x. Okay, and that is our left hand side is equal to our right hand side. Okay, this is a simple one, right? Quite easy. Like I said, if you did not follow the rules, this would have stumped you. Sec of x would have stumped you, because you needed to know that sec of x is equal to 1 over cos of x, and our rule says that, or the steps that I want you to implement, is to make everything in terms of sine or cosine on the side that you choose. Okay, so that one was quite simple, quite easy. I hope you like that one. Let's do another one, right? So let's say we have tan squared x cot squared x is equal to 1. Okay, so remember the rule. I'm not always going to write this down. We need to show that the left hand side is equal to the right hand side. Okay, so we need to choose a side, and the thing that's going to help us to choose a side is to ensure that we can make everything in terms of sine or cosine. Okay, we can already see from this, right, we have a 1 here, so you cannot choose the right hand side. Okay, so we have to choose the left hand side, and by looking at this, we know that tan of x is equal to sine of x over cos of x. Okay, so that's for sine, and cot is the inverse of tan. So if we're going to take this forward, we're going to can rewrite this as sine of x over cos of x all squared multiplied by cot. So cot is the inverse, so it will be cos of x over sine of x all squared, right? Because it's tan squared, cot squared, and we need to show that that's equal to 1. Okay, now we can already go ahead, and if you see my previous videos on the exponents, we need to distribute this into the brackets. So we now have sine squared x over cos squared x multiplied by cos squared x over sine squared x. And now it becomes very simple, right? We need to show that it's equal to 1. If we multiply, right, we can see that sine squared x will cancel out, cos squared x will cancel out. So we have 1 multiplied by 1 is equal to 1. So 1 is equal to 1. So we can show that our left hand side is equal to our right hand side. Once again, quite simple if we make everything into sine and cosine. Okay. So let's take another example, right? What if we looked at, or we have a question that we need to prove that, let me use it in red. We need to prove that cot of x, sec of x, sine of x is equal to 1. Okay, we can already see this is one we cannot prove the right hand side. We need to prove the left hand side. We need to make everything into sine and cosine. So we know that cot is the inverse of tan, so that can be rewritten in terms of sine and cos as cos x sine of x. Sec is the inverse of cos, so we can rewrite that as 1 over cos of x, and we already have sine of x. And we need to show that it is equal to 1. Okay. Now we can already see this taking shape, where I can just multiply this into there. So I can have this as cos of x over sine of x multiplied by sine of x over cos of x. And I need to show that this is equal to 1. And you can see it take shape clearly now, because cos and cos can cancel out, sine and sine can cancel out. We have 1 on the left hand side is equal to 1 on the right hand side, so we can show that the left hand side is equal to the right hand side. So this identity here is true, and we have proven that. Okay, it looked complicated until we were able to get it into this form here. Okay, this is actually a 2-step proof. Okay, so also take note of that, right? This was a 2-step proof. If you did not know how to go about taking it into a sine and cosine kind of depiction, you would think that you would not be able to go ahead with it. But look at the mark as well, right? Because usually the mark that is given for these identities will tell you how long it will take you to get to that answer, how many steps it will take for you to prove it. Because in this case, I would have just given you 2 marks to prove that cot x, sec x, sine x is equal to 1. And that would have told me or told you that it would have been like a 2-step or a 3-step process to get to this final proof. Okay, so let's look at another one, right? So let's say we have cos of x, sec of x, all over cot of x. He's saying this is equal to tan of x. Okay, now we can choose the right hand side, but we know that if you choose the right hand side, tan is sine over cos, and we can't do much with that to get that into this formula on the left. So let's choose the left hand side. We need to get it into cos and sine. So we can say that this is then equal to, we can show that this is then equal to cos of x. We'll leave it as cos of x. Sec of x is inverse, so we're going to write that as cos of x, all divided by cot of x, right? Now we know that cot of x is the inverse of tan of x. Now we can rewrite this. Okay, so we can rewrite this as cos of x over sine of x, but I'm not going to do that, right? Because if you're paying attention to what we are currently doing on the top here, you would already see that cos of x and cos of x will cancel out. So if I leave this as cot of x and we're saying I need to show that this is tan of x, okay, just stay with me. We now have this as 1 over cot of x, and I need to show that this is tan of x, and the inverse of cot is tan of x. So tan of x is equal to tan of x. We've proven that the left hand side is equal to the right hand side. Okay, so pay attention to how you are going about with this, right? Because if you picked up quite early on while you were doing this that this cot of x, cos of x was going to cancel out with this cos of x, you would have picked up, like I did, that you didn't need to convert this cot of x into cos of x over sine of x, because 1 over cot of x would have already proven this for me. Okay, so it's all about thinking ahead as well and understanding your identities, right? Because if you understood that this was equal to that, okay, 1 over this was equal to that, you would have went ahead and left it as it is and go ahead and complete and show the proof, right? So that one was a quite interesting one, and I like to just show you that one. Let's look at something slightly more complicated. Okay, so I need to show that sine of x tan of x is equal to 1 minus cos squared x over cos of x. Okay, so we can use either the left or the right hand side here. However, you can see that on the right hand side we only have cos, so I cannot get that into any form here where I can get sine in it or sine over cos in it, right? So I'm going to go ahead with the left hand side, right? And if you picked up the pattern so far, a lot of the times you should go ahead with your left hand side more than your right hand side, because a lot of the times your right hand side is more of the simplified answer. So if I take the left hand side, right, I need to get into sine and cos. I'm going to have sine of x. Let's change the color so you can see the difference. Let's do a bright blue. So we're going to have sine of x. Tan is sine of x over cos of x, and I need to show that this is equal to 1 minus cos squared x all over cos of x. Okay, now if I multiply that out, I would now have sine squared x over cos of x, and I need to show that that's equal to 1 minus cos squared x over cos of x. And if you've seen this, or if you was paying attention with your identities, you would already understand that these two are equal. Now, how are these two equal? We know that sine squared x plus cos squared x is equal to 1. So sine squared x is equal to 1 minus cos squared x, which is that and that. Okay, so because we know this identity here, we can show this, that sine squared of x is equal to that. So we now have 1 minus cos squared x over cos of x is equal to 1 minus cos squared x over cos of x. So we know that our left hand side is definitely equal to our right hand side. Okay, so trick again, know your identities. Okay, know your basic identities, because they are the ones that's going to help you a lot when you see these type of questions, these proof type of questions. So let's go ahead and let's do another one, right? So let's go ahead and let me start this on a new page. Let's do cos squared x minus sine squared x is equal to 1 minus sine squared of x. Okay, so we know that this is in sine. We only have sine here, but we have cos and sine on the left hand side. So let's go with the left hand side, right? Let's see if that works, right? The rule that I was telling you earlier on, most cases you'll use the left hand side. Now we know that sine squared x plus cos squared x is equal to 1. So I can show that cos squared x is equal to 1 minus sine squared x. Okay, so if I take this and plug that into our original question, I now have 1 minus sine squared x minus sine squared x, and I must show that that's equal to 1 minus 2 sine squared x, which I already did just by using that, our basic formula, because this is now 1 minus 2 sine squared x. These are like terms, so I can add them, is equal to 1 minus 2 sine squared x. So I now have the left hand side is equal to the right hand side. Once again, very, very important. Let me actually highlight this to you. Know your basic trig identity. Okay, know the basic, right? So know that our sine squared x plus cos squared x is equal to 1, and from there you could get this. Okay, that was quite simple because we knew what the identity was. Let's do another one, right? Let's say we have sine x tan of x plus cos of x is equal to sec of x. Okay, so what do we do in this case, right? We know we need to work on one of the sides, the left hand side or the right hand side, and we need to make everything in terms of sine and cos. I'm going to choose the left hand side again. So I'm going to say that if we have sine of x, we're going to leave sine of x as is. If we have tan of x, we're now going to write this as sine of x over cos of x plus cos of x, and I need to show that that's equal to sec of x. Now I can distribute that into the brackets, so I'm now left with sine squared x over cos of x plus cos of x, and I'm going to show that that's equal to sec of x. Okay, so we are now going to look at something that we know in maths and go down to basics of finding the common denominator. So we need to find the common denominator here. And what is the common denominator, right? You place that over 1, because the common denominator will have to be cos of x. So if I take this further with the common denominator being cos of x, this will remain as sine squared x over cos of x, plus, if we use the common denominator as cos of x, so we're multiplying both sides by cos of x, dividing both sides by cos of x, so we're going to get cos squared x over cos of x is equal to sec of x. Okay, so where are we now? Because we have the same denominator, I can rewrite this as sine squared x plus cos squared x all over cos of x, and I need to show that that's equal to sec of x. Now what do you think we do here? Once again, our basic identity comes into play. We know that sine squared x plus cos squared x is equal to 1. So we now have 1 over cos of x is equal to sec of x. And that is correct, because 1 over cos of x is the inverse. So sec of x is equal to sec of x. we prove the left hand side is equal to the right hand side. Okay, so something new in here, we go back to our basics in terms of maths. We need the common denominator. Okay, and by using the common denominator up here, which we found was cos of x, we were able to take this further into an identity we can understand, where cos squared x plus sine squared x is equal to 1, and we're able to find the inverse of sec of x or cos of x. Okay, so that one was also quite simple. Okay, let's do another example, right? Let's do something also exciting. Maybe choose another color. Let's choose this color, the maroon. Let's say we have sec of x minus cos of x, and we say that that's equal to tan of x sine of x. Now I'm going to choose the left hand side, right? Again, let's choose the left hand side. Let's solve this. So if I choose the left hand side, we know that sec of x can be rewritten as 1 over cos of x minus cos of x, and I need to show that that's equal to tan of x sine of x. Okay, so similar to the previous example, we're going to use the greatest common denominator, and we know that from here we can see that it's cos of x. So using that method, we're going to have 1 over cos of x minus cos squared x over cos of x is equal to tan of x sine of x. Okay, so I still need to get this into that form. Okay, so let's go ahead and rewrite this as 1 minus cos squared x over cos of x is equal to tan of x sine of x. Okay, so just putting everything over the common denominator. Now let's do something with the identity again. We know that, once again, sine squared x cos squared x is equal to 1. So I know that sine squared x is equal to 1 minus cos squared x, and that is that. Okay, how cool is that? So using our basic identity once again, we're able to get this into a simpler form. So we got sine squared x over cos of x is equal to tan x sine x. Now, what do I do here? How do I get it from that to that? I can rewrite this as sine of x over cos of x multiplied by sine of x. This is the exact same thing as that, multiplied by tan of x sine of x. Okay, we know that that is tan of x. We can just bring that down. That's sine of x. That's equal to tan of x sine of x. So we prove that the left hand side is equal to the right hand side. Quite simple. Once again, being able to use our basic trig identity and use that to solve this or prove this identity. Quite interesting, eh? Let's do 2 more for this video. Let me choose another one. Let's use this color. So let's say I have 1 over cos of x minus cos of x over 1 plus sine of x. I need to show that that's equal to tan of x. Now I'm going to choose the left hand side. You can already see that there's a lot to do here on the left hand side. Okay, and let's use our previous knowledge. We're going to directly go into finding the common denominator or common denominators here, where our common denominator would be our cos of x and our 1 plus sine of x. So let's write that down. So that's cos of x into 1 plus sine of x. Okay, so our numerator then would be 1 plus sine of x minus cos squared x, right? We multiply that across and we need to show that that's equal to tan of x. I'm just going to change the color. Sorry about that. I should have done that earlier. Let's choose a let's just choose this. Okay. Now we know that again sine squared x. Let me write this down for you, right? Sine squared x plus cos squared x is equal to 1. So sine squared x is equal to 1 minus cos squared x. Okay. Now why did I write this out? If you look at the top here, that's 1 minus cos squared x. Okay. So it's very, very interesting for you to actually be able to identify and look at this problem and see that, right? 1 minus cos squared x is there. So I'm going to rewrite this as sine of x. And I saw that 1 minus cos squared x is sine squared x. Okay. So that's plus sine, positive sine squared x. And that's all over our cos of x, our 1 plus sine of x. And that's equal to tan of x. That's what I want to show, or we need to show, right? Now I can factor out sine of x. So I factor out sine of x on here. I can rewrite that as 1 plus sine of x into cos of x, 1 plus sine of x, and I need to show that that's tan of x. Once again, we went back to basics by factoring that out, and I can just take that, and now I have sine of x over cos of x is equal to tan of x, and that is tan of x equals to tan of x. So we prove that the left hand side is equal to the right hand side. Okay. Once again, we used our basic identity to help us simplify this, but one trick here was to actually identify that you could rewrite this entire thing as sine of x plus 1 minus cos squared x. Okay, a trick for you to understand that and to also understand the identities, right? Because by understanding that that identity actually existed, you were able to go ahead and simplify this and prove this identity, this trig identity. Okay, I'm going to do a final one for this video. So I'm going to say that sine of x over 1 plus cos of x plus 1 plus cos of x over sine of x is equal to 2 over sine of x. Okay, now of course we're going to go to the left hand side. Take the same approach, greatest common denominator, so it's that sine of x into 1 plus cos of x. Okay, and our numerator would be sine squared x into 1 plus cos of x all squared, right? And we need to show that that's 2 over sine of x. Okay, before we proceed, right, we need to go once again back to basics, and we need to take this and we need to FOIL that out. So if you do that, we'll have this as sine squared x, okay, plus 1 plus 2 cos of x plus cos squared x all over sine of x 1 plus cos of x. Now if you look at this, we have sine squared x, we have cos squared x, and we know from our identity that is 1. So we'll have 1 plus 1 plus 2 cos of x all over sine of x 1 plus cos of x. And that is 2 plus 2 cos of x all over sine of x into 1 plus cos of x and we need to show this as 2 sine of x. Okay, I did not write that, but that's what we need to show, right? Now, once again, back to basics in terms of maths. Let's factor out. We can factor out the 2. So I can pull out 2 and we can show 2 into 1 plus cos of x all over sine of x, 1 plus cos of x, and that's it. We need to show is 2 over sine of x. And we proved it, right? Because we can now see that that and that cancels. We are now left with 2 over sine of x, which is equal to 2 over sine of x. Okay, so our left hand side is equal to our right hand side. And that is our final example on proving identities. I hope you enjoyed this video and paid very close attention to how I went about solving these problems, especially from knowing and understanding our identities. So check out my previous video on that. Knowing and understanding, going back to our maths basics, which is using FOIL, finding the greatest common denominator, always ensuring that we either pick the left hand side and right hand side, and that will facilitate you in solving this problem. And you must ensure that the side that you pick, you can get it in terms of sine and cosine, but at the same time also understand your identities, because like in the one example we did, we did not need to take the cot and change it into cos over sine. We had the ability to see that we could use the inverse of cot and prove that it is equal to 10. So be aware of these types of problems, these types of scenarios. That was actually a very good example, because you do know your lecturers or your teachers like to trick you some way, and although the basic rules say let's make everything sine and cosine, there are exceptions to it if you can see exactly what you need to do and how you need to go about getting to your final answer. So thank you for watching this video. Please like and subscribe. I will be uploading more examples around trig identities as they come to me. Also, thank you for the person who had emailed me. Unfortunately, did not give me your full name, but thank you for emailing me and asking me to create such a video. It was very interesting creating such a video, and I hope this does help you and help all of the viewers out there. Until next time, all the best with your exams, all the best with this section on trig identities, and ensure that you go in to your exams with all this hard work, all this prep, and you will do well. So thank you, and we shall see each other next time.